Hi guys, welcome in today's video. So in the last video, we have just seen how we can apply binary search, what is binary search, what is the time complexity of the binary search, and what are the cases. We have talked about the cases of the binary search, right? The case one, which is the target is equals to the middle element, and target is less than or target is smaller than the middle element. So we have talked about these two cases, and we are going to apply those cases into this question. Okay. So the question is, given a sorted array, find the floor of the K. So what is floor? The question is, what is floor? Floor is floor is the maximum of all the elements which are or which is less than K. Okay. So just focus on this word, maximum of all the elements less than K. So what is our K? Our K is 5. Okay. And the elements. Okay. So elements less than k are -5, 3, and 4. Okay. And which is the maximum of it? This is the maximum. So answer is 4. 4 is the floor of our target 5. Okay. So I hope you understand the question, what the asking of this question is. So how to approach this question? So let's talk about the brute force approach. The brute force approach is what we have to iterate every element one by one. Okay. And if we found our element which is just equal to or greater than 7, we will return the previous answer. Okay. So in this case, the time complexity is O of n, because let's say if my k is 22, so we have to iterate all the elements till here last. Okay. And this is my answer in that case, because the last, this is also less than 22, but after this we can't iterate. So this is the possible answer. And in this case, we have iterated all the elements. So that's why the time complexity for this linear search is O of n, right? Because in worst case, and like I said in the previous video, time complexity always works on the worst case. We have always considered the time complexity on the worst case. Okay. Now, can we apply binary search here? Can we apply? Think about it. Can we apply binary search here? We can. We can if or all the three cases are successfully implemented. Okay, what are those three cases? So my three cases, one is case one, which is middle element. Okay, so if my target is equals to the middle element a of m, what we need to do? If my target is, let's say the target is 10. This is my target, and this is my middle element. If my target is 10, is it the answer? Is it the answer? Just think about it. If my target is 10, is it the answer? So if my target is 5, so what the floor is saying, let's check once again. Maximum of all the element which is less than k. Okay. So we have to find all the elements which is less than the k, less than target. So my target is 10. We have to find the elements which is less than the target. So if my target is equals to the middle element, so this is not the answer by the definition, right? Because we have to find the the smaller ones. Okay. And if we have to find the smaller ones, what we have to do? We have to search in the left side. Do you agree? Do you agree this case? We have to search on the left side. right? I hope you agree, because if we search on the right side, then this element is greater, but we have to find the smaller ones, right? So we have to search on the left side, and the formula for searching the left side is my h. This is my l. This is my h. H should come at before m. So h should be m minus 1. This is my case 1. What is my case 2? My case 2 is if my target is greater than the middle element. Let's make the target. Okay. Let's make the target. This is my L, this is my H, and this is, let's say, this is my middle element. If my target is 10, okay. So in this case, my target is, just think about it. Okay, let's do one thing. Let's talk about case 3 first, then I will come back to case 2. And my case 3 is k is less than the middle element. Okay. So again, let me take this array. This is L, this is H, and this is my middle element, let's say. So my target, which is 5, which is less than the middle element. Yes, in this case, it is true. So if it is less than the middle element, let's say it is less than the middle element, target is less than. So where we have to look, my possible answer, where we have to look? We have to look on the left side, because smaller than this element is always lie on the left side. Do you agree this? Right? So my H should be on the left side of the middle element. So my H should come here. Make sense? So this is my case 1 and case 3. Let's talk about the case 2, because my condition is a condition of finding answer lie inside the case 2. Let's see how. Let's see if my target is greater than the middle element. So my target is 10 and my middle element is 7. Okay. And this follows. So what okay, this could be my answer. This could be my answer, because this is less than k, and we have to find the elements which is less than k. Okay, so this could be my answer. Yes, so I will update my answer equals to equals to answer equals to a of m. Make sense? Okay, why this is the answer? Because if k is greater than this element, so this element could be the answer. Could be, not always, could be the answer. I'll tell you why. Because let me take one more example with you. Let's take this value as a 16. Okay, let's take this value as a 16. First, first tell me, uh, is this understandable for you? Why this is the answer? If k equals to the middle element, we have to search on the left side, because we have to find the smallest one. Equal to is not allowed. If k is less than, then again we have to search on the left side, because this element is greater. If this element is greater, then this can't be the floor. Greater element can't be the floor. So we have to search for the left side. These two cases are fine. Now for case 2, if my middle element is smaller than this element, then this could be the answer. This is what the asking is. We have to find the element which is less than k. We will see what is the maximum element, but we have to find the elements which is less than k. And this element is less than k. So this could be my answer, right? So I hope you agree this. Now let me take another example. Okay. Now, right now, my target is 16 and my middle element is 7. Okay. So my target is 16 and my middle element is 7. So my middle element is lesser than the target. So this could be as per the question, or as per the condition, element which is less than k could be the answer. So this element is this element is less than k. So this could be the answer. But you can see this is not the maximum of it, because what are less than 16? Less than 16 are 12, 10, 7, 4, 3, and minus 5. These are all the elements which are less than 16, and maximum of it is 12. So 12 should be the answer. But in this case, I have updated my answer is 7, the middle element. So what we can do, we can say that by checking this scenario, we can say that my maximum could be on the right side, because it can't be on the left side, because you are already at the maximum of the left side. If this is the answer, you are already at the maximum of the left side. It doesn't required for checking for 4, because 7 4 can't be the answer if 7 is the answer, right? So my answer could be here as well, not 16, only till here. So what I can do, I have to search on the right side. So if I have to search on the right side, my L should come here. That's it. That's it. Okay. Now let me uh, run for 16. Let me run for 16. Let me dry run for 16. Okay. These are my L. L is here. H is here. M, case, search space, and formula. Okay. Now my L is 0 right now. H is 7 right now. So M is 3. My M is here. So A of M is K is 16. A of M is 7. So 16 is greater. That means K is greater. K is greater than 7. If K is greater than 7, if target is greater than 7, then we have to update my, okay, we will see the formula. But my search space is right side. Right side. So if search space is right side, so L is equals to M plus 1, because L will come after the M, and my answer is updated. Answer is equals to A of M. Okay. Now L is updated. Now L is M plus 1, which is 4, and this is 7. 4 plus 7, 11, which is half is 5. So where's my 5? 5 is here. Okay. So again, 16 is greater than 5. Sorry, 16 is greater than 12. A of 5 is 12. So again, we have to search right. And this time also, L should be increased M plus 1. L should come here. And my answer is updated once again. A of M. Here my answer was, what was my answer? 7. And now my answer will be, where was my M at fifth place? 12. Okay. Now my L is updated. This time it is 6. This time it is 7. 6 plus 7 is 13. 13 divided by 2 is 6. So again, this is K, and array of 6. Array of 6 is here, 16, which is equal. If it is equal, right? If it is equal, then what we can do, if it is equal, then what is our case? This is case 1, right? This is case 1. If it is case 1, we are searching on the left. Searching on the left. If we are searching on the left, what was the formula? H is equals to M minus 1. H is equals to M minus 1. That's it. Now, now H is equals to M1, M minus 1. L should be, L remains same, and H is 6. 6 and 6 is, middle element is 6. So 16, again, this is same. This is same, right? So 16 equals to 16. Now go to left. H equals to M minus 1. Now L remains the same. H is 5. Now here my L is greater than H and my condition comes out of the loop and we will return answer, which is 12. And this is the answer. As you can see, this is just smaller than 16, right? So let me write the pseudocode here. So I'm initializing L as 0, H is equals to N minus 1. I will say a while loop and I'll say L should be less than equals to H. I am updating the or populating the M middle value. Now my three cases. If K, my target is equals to middle element. So my floor will always lie on the left side, right? Left side, search left. And what was the formula of searching left? H should come before M. Else if K is greater than A of M, if K is greater than A of M, we are updating yes, this is what we wanted because if middle element is smaller, this could be the answer. So answer equals to A of M. But we have to search on the right side to find if any element which is greater than this but smaller than this. So we have to search on the right side. So L is equals to M plus 1. And last condition, which is less than K. So if K, let me write it for you, but you can ignore this part. K is smaller than A of M. So if K is smaller, then we have to search on the left side. If K is smaller, think about it. 1, 2, 3, 4, 5. K is 4, but my middle element is 3. Sorry, my middle element is 5. So K is smaller. So let me write one more. Yeah. So there's no point of searching here because we always have to find the smaller element, right? So we have to search on the left side. That's it. That's it. And my while loop ends. If my while loop ends, I will return answer. And I have to define a variable answer and I'm assigning a minimum value to the answer. At first, I'm assigning the minimum value. Why? Because let's say if I don't find my answer, then it will return the minimum value of integer. And by checking the minimum value, we can say that the answer could not be found in the given array. So if talking about the time complexity is always over log n, why is that? Because of this condition. This is the, you can say that this is the heart of this binary search heart. And because of this, the time complexity is reduces to from n to log n. Okay. So I hope you understand this question. If you face any doubt, if you have any question, you can simply comment on this video and you can ask. I will reply to each question. Okay, that's it for now. We will see the next video with the new question. Bye.